What is consciousness? Most of us take our awareness for granted, yet it is one of the greatest mysteries of the human brain. Despite centuries of philosophical inquiry and scientific exploration, consciousness remains an elusive concept, as intangible as it is fundamental to our experience as humans. Scholars from various fields, including philosophy, psychology, and neuroscience, have attempted to decode the nature of consciousness. Some posit that consciousness arises from simple brain processes, while others argue it transcends mere biological activity. According to a 2020 study published in Nature, the human brain can process information at astonishing speeds. Researchers concluded that our average conscious mind can absorb roughly 60 bits of information per second, which is a minuscule fraction compared to the 11 million bits our subconscious processes at the same time. This stark contrast raises an intriguing question: are we merely the byproducts of a biological machine, or does our consciousness give us a significant edge, a deeper connection to reality? To explore this further, we must delve into the fascinating work of neuroscientists who study the brain's intricate architecture. One influential figure in this arena is Francis Crick, co-discoverer of DNA, who posited in his later years that consciousness arises from specific neural networks in the brain. His research, in conjunction with neuroscientist Christoph Koch, led to the development of the cortex theory, which emphasizes the role of particular brain regions in processing conscious thought. This theory posits that consciousness is not a singular entity but rather a collection of simultaneous processes. With advanced imaging techniques, we can observe these networks lighting up during various tasks. However, we are still far from fully understanding how subjective experience arises from these processes. This brings us to the tantalizing notion of theories of consciousness. The integrated information theory, championed by neuroscientist Giulio Tononi, suggests that consciousness is a measure of how much information is integrated within a system. In simple terms, the richer the connection between different parts of the brain, the higher the conscious experience. For example, people with brain injuries often report changes in their consciousness, showcasing how fragile and complex our awareness truly is. Moreover, cases of near-death experiences and altered states of consciousness challenge the conventional view of consciousness being solely a product of brain processes. Many individuals recount vivid experiences during cardiac arrest, leading to questions about what consciousness truly is. As we unravel the layers of consciousness, we cannot ignore the implications these revelations have on our understanding of the self. If consciousness is not a singular, fixed entity, what does that mean for our identity? As we conclude this chapter, ponder this: have you ever felt an aha moment, as if a sudden spark ignited in your mind? What if those moments reveal profound insights into the essence of who we are? Join us next as we explore the remarkable adaptability of the brain, an extraordinary phenomenon known as neuroplasticity, which will change everything we think about learning and recovery. Neuroplasticity is an exhilarating concept that challenges the traditional notion that the brain is a fixed structure. This capacity for change allows the brain to reorganize itself by forming new neural connections throughout life, fundamentally altering the way we understand learning and recovery. Imagine overcoming a debilitating injury, only to find that your brain can adapt and relearn forgotten skills. In 2000, a groundbreaking study by neuroscientists at the University of California showed that patients recovering from strokes could regain movement by engaging in repetitive tasks, essentially rewiring their brain pathways. Using fMRI scans, researchers witnessed remarkable changes in the brain's structure and activity as patients learned to perform tasks again. This capacity extends far beyond recovery from injury. It encompasses the potential for lifelong learning. Take the example of a renowned pianist who lost the use of his right hand in an accident. Through dedicated practice and effort, he not only adapted to play with his left hand but also discovered new techniques and styles that illuminated unknown talents. His journey underscores the potential locked within each of us to reshape our brains and improve capabilities. This plasticity is not just limited to motor skills. Cognitive training programs have emerged that demonstrate how engaging the brain in novel tasks can enhance memory and cognitive function, showcasing the brain's remarkable adaptability. Research conducted at the University of Cambridge revealed that learning a new language can significantly alter brain structure. Participants engaged in intensive language courses showed increased gray matter density in regions of the brain responsible for language processing, a tangible testament to neuroplasticity at work. Moreover, the brain's plastic nature holds immense potential for therapeutic interventions. For instance, in treating mental health conditions like PTSD or anxiety disorders, techniques such as cognitive behavioral therapy utilize the principles of neuroplasticity to rewire negative thought patterns and replace them with healthier responses. Yet, the embrace of neuroplasticity raises intriguing questions. How do our environments and experiences shape our brains? Could the information overload of our digital age lead to adverse effects on cognitive function? Consider the alarming rise in mental health issues among younger generations. Can it be linked to the overstimulation of our brains in a hyper-connected world? As we explore these puzzles, let's not forget the profound implications of neuroplasticity in our daily lives. With a growth mindset, we can embrace challenges, knowing that effort and perseverance can reshape our cognitive abilities over time. In our next chapter, we'll examine how memory works, a complex but fascinating aspect of the human brain that remains intertwined with our identity. What secrets does our memory hold, and can we truly trust it? Memory is often regarded as the bedrock of our identity. It shapes not only who we are but also how we understand the world around us. Yet, memory is a complex construct, riddled with mysteries that challenge our perceptions of reality. What if I told you that our memories are not perfect recordings of events but rather dynamic processes that evolve over time? Research suggests that each time we recall a memory, we may inadvertently modify it, leading to distortions and inaccuracies. A striking illustration of this phenomenon comes from a 2007 study led by Elizabeth Loftus, a pioneering figure in memory research. Her work revealed how eyewitness testimonies could be manipulated simply by altering the phrasing of questions asked after an event. Participants exposed to misleading information reported false memories that contradicted their initial experiences. This concept has profound implications for the criminal justice system, where the reliability of memories can make or break a case. It forces us to reconsider the veracity of our recollections. Are our memories mere constructs influenced by external factors, or do they possess a semblance of truth? Beyond accuracy, memory types also add complexity to our understanding. There are different types of memory, including short-term, long-term, implicit, and explicit memory, each processed and stored differently within the brain. Neuroscientists have identified specific brain regions associated with these memory types. For instance, the hippocampus plays a crucial role in the formation of new memories, while the amygdala is tied to emotional memories. This interconnection reveals not just how memories are formed but why certain experiences leave lasting impressions. Emotional memories are particularly impactful. Consider the memories of significant life events, weddings, births, losses. These moments are often vividly etched in our minds due to the emotional connections they carry. The intensity of our feelings elevates those memories, making them a vital part of our personal narratives. However, what happens when those memories become sources of pain? Traumatic experiences can lead to PTSD, where the memories of those events replay vividly, causing immense psychological distress. This highlights the duality of memory. It is both a source of joy and a potential burden. Throughout history, cultures have developed techniques to preserve memory, from oral traditions to written records. Today, with technology's aid, We document our experiences through photographs, videos, and social media, reshaping how we store and share memories. Yet, as we navigate this digital landscape, we must ask ourselves, are we creating lasting memories or mere snapshots of moments? As we look ahead, join us in our next chapter where we will delve into the fascinating relationship between memory and identity. How do our memories define who we are? What happens when we lose them? Have you ever wondered how your memories shape your identity? The relationship between memory and identity is an intricate tapestry weaved by the experiences that define us. Our memories are not just data points, they are the threads that stitch together the narrative of who we are. The concept of identity is multifaceted, encompassing our beliefs, values, cultural background, and personal experiences. When we reflect on poignant memories, we begin to understand how they influence our decisions, relationships, and goals. Consider the case of Clive Wearing, a British musician who suffers from profound amnesia following a viral infection that destroyed parts of his brain. He experiences a memory span of just seconds, unable to form new memories while retaining limited recollections from his pre-amnesia life. Waring's condition raises critical questions about identity. If memories are fundamental to who we are, what happens when they evaporate? For Waring, every interaction with his wife feels like meeting her for the first time, yet the emotional bond remains. This dichotomy highlights that while memory plays a vital role in shaping identity, our essence may transcend mere recollection. Psychologists suggest that identity is a fluid construct shaped by narratives we tell ourselves and those around us. Thus, even with fragmented memories, individuals can rebuild their identities based on current experiences. This adaptability illustrates the resilience of the human spirit. Conversely, identity crises can occur when individuals grapple with dramatic shifts in memory, such as traumatic brain injuries or dementia. In these cases, the struggle to reclaim identity underscores the intricate interplay between memory and self-perception. Moreover, the phenomenon of false memories poses another layer of complexity. Research indicates that our minds can construct memories of events that never occurred, reshaping our identities based on inaccuracies. For instance, individuals may confidently recall details of events that others remember differently, leading to conflicts regarding personal histories. The implications extend into our cultural narratives as well. Collective memories shared within communities shape societal identities, influencing worldviews and driving movements. The recollection of historical events can unify or divide populations, emphasizing how memory acts as a cornerstone of identity on both individual and collective levels. As we navigate the enigma of identity, we must acknowledge the multifaceted role memory plays in defining ourselves. In our next chapter, we will explore cognitive biases, the mental shortcuts that shape our perceptions and decisions. Are we truly in control of our thoughts, or are our minds influenced by unseen forces? Cognitive biases are the invisible hand guiding our decisions and shaping our perceptions of reality. These mental shortcuts influence everything from our beliefs to our judgments, often leading us astray. What are cognitive biases? They are systematic patterns of deviation from norm or rationality in judgment. Psychologists have identified several types of biases, including confirmation bias, anchoring bias, and availability heuristic, each affecting how we perceive and interact with the world. For instance, confirmation bias leads individuals to favor information that confirms their pre-existing beliefs while ignoring evidence to the contrary. This bias can create echo chambers, particularly in the age of social media, where algorithms curate content that reinforces our views. Consider the political landscape. How often do we see individuals engage in heated debates, each armed with selective facts that support their narratives, while disregarding opposing viewpoints? This disconnect fosters division and polarization in society. Another intriguing bias is the anchoring effect, where people rely too heavily on the first piece of information encountered when making decisions. For instance, when negotiating a salary, the initial offer often serves as an anchor, shaping subsequent discussions despite not accurately reflecting the value of the position. Confirmation bias and anchoring present challenges, but the concept of the availability heuristic is perhaps the most insidious. This bias suggests that individuals assess the likelihood of an event based on how easily examples come to mind. When we hear about a plane crash, we may overestimate flight risks, despite statistics indicating that flying remains one of the safest modes of transportation. The implications of cognitive biases stretch across multiple domains, from personal relationships to professional environments. In the workplace, biases can hinder diversity and inclusion efforts, as hiring managers may unconsciously favor candidates with similar backgrounds or experiences. In our increasingly globalized world, recognizing and mitigating cognitive biases is crucial in fostering understanding and collaboration between diverse groups. As we reflect on the profound impact of cognitive biases, it becomes evident that our minds are not as rational as we might believe. Our perceptions of reality can be shaped by unseen forces, leaving us vulnerable to misconceptions and errors in judgment. As we conclude this chapter, consider this: how many aspects of your life might be influenced by your own cognitive biases? In our upcoming chapter, we will delve deeper into the relationship between emotions and decisions, exploring how our feelings sway our reasoning. Intuition is often seen as a mysterious, almost magical guide in our decision-making. But what if I told you that beneath this seemingly simple instinct lies intricate neural processes that reveal more about our cognition than we might believe? When we talk about intuition, we're often referencing gut feelings, those abrupt insights that seem to arise from nowhere. It's that split-second understanding of a person or situation that we can't quite articulate. This sense of knowing is a product of our brain's ability to process vast amounts of information subconsciously, allowing us to react without deliberation. Research has shown that our brains can begin processing information before we are even consciously aware of it. Studies in cognitive science illustrate that the brain can recognize patterns based on past experiences and knowledge. For example, a 2009 study by researchers at the University of Washington found that the brain's ability to recognize subtle cues can lead to accurate gut feelings. They found that individuals could make correct judgments about people's emotions without knowing why they felt that way. Let's dive deeper into the science behind this phenomenon. Neuroscientists believe that the anterior insula, a small region of the brain, plays a significant role in intuitive thinking. This part of the brain integrates sensory information with emotional experiences, resulting in quick, often accurate, judgments. For instance, during a poker game, an experienced player might notice subtle changes in an opponent's facial expression or body language, leading to an intuitive decision to bluff or fold. Furthermore, researchers have discovered that our brains are wired to connect emotions with sensory stimuli. This connection demonstrates that intuition is not merely a random thought but rather a complex interplay of emotions, memories, and sensory input. A study published in the journal Cerebral Cortex suggests that our decisions can often be influenced by past experiences and conditioned responses, which form the basis of our intuitions. This means every single experience you have shapes how you perceive the world, creating an intricate web of knowledge that informs your gut feelings. However, while intuition can lead us to make wise decisions, it can also mislead us. Cognitive biases can distort our intuitions, leading us to faulty conclusions. For example, confirmation bias can trap us into seeing only information that supports our existing beliefs, while ignoring evidence to the contrary. Additionally, the Dunning-Kruger effect illustrates the paradox of intuition. Individuals with lower abilities in a given area often overestimate their capabilities, convinced of their intuitive grasp of the subject. Psychologists have found this effect affects everything from hiring decisions to public policy. Our intuitive responses, while deeply ingrained, can sometimes lead us astray. So how can we harness the power of intuition while being mindful of its pitfalls? The key lies in awareness, becoming conscious of when you are making intuitive decisions and examining the underlying factors. Practicing mindfulness can help us slow down our thought processes and recognize when we are acting on gut feelings. Engaging in reflection or dialogue can also improve our decision-making, allowing us to weigh intuition against logic. As we close this chapter, remember that intuition is a double-edged sword. It can propel us toward success or lead us to misjudgments. The challenge lies in finding balance, embracing our intuitive abilities while remaining vigilant against their possible distortions. Reflect on a moment when your intuition guided you correctly. But ask yourself, how often do you blindly trust that instinct? The answer may surprise you, as it reveals more than just the capabilities of the human mind. It unveils the very essence of who we are. What is creativity? Is it merely an expression executed with paintbrushes or musical notes? Or does it extend deeper into the neurological structures of the brain? Research suggests that creativity is far more complex and involves various brain regions working in concert. From brainstorming to problem-solving, the act of creation taps into our cognitive resources in remarkable ways. One of the most notable studies on creativity comes from the work of neuroscientist Dr. Roger Beatty, who explored how different brain networks contribute to creative thinking. Beatty and his team used functional magnetic resonance imaging, fMRI, to observe the brains of individuals as they engaged in creative tasks. They identified two major networks: the default network, which activates during spontaneous thought, and the executive control network, which sharpens that creativity into focused action. Interestingly, one of the key players in creativity is the default mode network, DMN. This network is often associated with daydreaming, self-reflection, and imagination. When we allow our minds to wander, when we're in the shower or taking a walk, this network lights up, revealing the importance of free thought and fostering creativity. According to Dr. Scott Barry Kaufman, allowing ourselves unstructured time can enhance creative output, as it gives the brain room to innovate. But what about those moments of aha? The sudden bursts of insight? This phenomenon can be traced back to the brain's temporal lobes. Neuroscientists have shown that increased activity in these areas often correlates with moments of inspiration. In 2007, a study published in the journal Nature demonstrated this link by observing participants who experienced creative insights. However, the relationship between creativity and the brain is not merely about the processes within but also how external factors influence them. For instance, environments rich in stimuli can promote creative thinking, as seen in studies where participants in vibrant, dynamic settings produced more innovative ideas. Moreover, while we often celebrate individual creativity, it's crucial to recognize the social aspects as well. Collaboration can ignite sparks of creativity that solitary work may not produce. The collective brainstorming efforts often lead to breakthroughs that solitary efforts struggle to achieve. However, societal pressures can also hinder creativity. The fear of failure or judgment can stifle innovative thinking. Many creative individuals often face mental health challenges as they navigate their ideas in a world that may not readily accept them. Historical figures like Vincent van Gogh and Ludwig van Beethoven battled personal demons that sometimes clouded their creative genius. So how can we foster creativity in our lives? Research suggests techniques such as mind mapping, taking breaks, and engaging in diverse experiences can enhance creative thought. Introducing constraints can also spark creativity. By limiting options, we may force our brains to think outside the box. As we conclude this chapter, contemplate the times you felt particularly creative. Was it in solitude or during collaborative efforts? Consider your environment and emotional state during these experiences. Creativity is not merely a talent, it is a complex interplay of neural activity, emotions, and context. The next time you feel inspired, remember, there's a whole world of neuroscience driving your innovative spirit. Close your eyes and think back to a dream you've had. What was it about? Dreams have captivated humans for millennia, serving as a portal to the subconscious. But why do we dream? What purpose do these nightly visions serve? Science has been grappling with these questions, uncovering fascinating insights into the mysterious world of dreams. One prominent theory is that dreams help process emotions and experiences from our waking lives. According to Dr. Matthew Walker, a sleep scientist and author of Why We Sleep, dreaming is a form of emotional regulation. During REM sleep, our brain replays memories, often in bizarre and novel ways, allowing us to work through feelings we may not fully comprehend while awake. In 2013, researchers at the University of California, Berkeley, conducted a groundbreaking study that linked dreams to the consolidation of emotional memories. Participants who underwent REM sleep after learning new emotional information exhibited enhanced recall the following day. This suggests that dreams play a pivotal role in solidifying our emotional experiences and can lead to greater psychological resilience. However, dreams can also be a source of creativity and problem-solving. The famous chemist Auguste Kekulé had a breakthrough regarding the structure of benzene after dreaming of a snake biting its tail. Dreams can provide novel solutions, helping us approach problems from unique angles. Yet, not all dreams are sweet. Nightmares can trigger anxiety and stress responses, reflecting unresolved conflicts or fears. Approximately 80% of children experience nightmares, but adults are not immune. Many face recurrent nightmares related to trauma or stress. Interestingly, the brain shows remarkable activity during dreaming. Neuroscientists have found that the prefrontal cortex, responsible for logical reasoning, is less active during REM sleep, while the emotional centers are more active. This explains why dreams can be so irrational and bizarre, blending elements of reality with flights of fantasy. So what can we do to enhance our dreams? Keeping a dream journal, practicing lucid dreaming techniques, and creating a sleep-friendly environment can all contribute to richer dreaming experiences. Engaging in regular mindfulness and meditation practices may also enhance the vividness and recall of dreams, flooding the brain with creativity upon waking. As we reflect on this chapter, think about your most vivid dream. What message did it convey, if any? Dreams are not just random images. They are woven into the tapestry of our minds, serving purposes that are still unraveling. The next time you drift off to sleep, know that your brain is embarking on a journey as profound as it is mysterious. Humans are social beings, intricately wired for connection and interaction. But how does our brain facilitate these complex social behaviors? The answer lies in a fascinating interplay of neural circuits that dictate everything from empathy to aggression. Understanding these mechanisms offers profound insights into our social nature. At the heart of social behavior is the limbic system, especially the amygdala, which plays a crucial role in processing emotions. This almond-shaped structure helps us assess social cues and react appropriately to various situations. For example, a study from Harvard University demonstrated that individuals with damage to the amygdala struggled to recognize fear in others, underscoring its vital function. Furthermore, the concept of mirror neurons has revolutionized our understanding of empathy. First discovered in the early 1990s, these neurons activate both when we perform an action and when we observe someone else performing that action. When we see someone smile, our mirror neurons fire, creating a shared emotional experience. Moreover, research has shown that our ability to empathize is not just instinctual, it can be cultivated. Neuroscientists like Dr. Tanya Singer have explored how mindfulness practices can enhance empathetic responses. In one study, participants who engaged in loving-kindness meditation exhibited heightened empathy and compassion levels. On the flip side, the brain also holds the keys to our darker impulses. Aggression, for instance, has been linked to heightened activity in the amygdala. A 2014 study found that individuals with aggressive tendencies often showed greater amygdala reactivity to perceived threats, indicating a biological basis for these behaviors. Interestingly, how we navigate social hierarchies also reveals the brain's intricacies. Research indicates that the prefrontal cortex is involved in decision-making within social contexts, allowing us to assess relationships and power dynamics. For instance, studies have shown that individuals in leadership positions exhibit more significant activity in this area when making decisions that affect their teams. As we consider the brain's role in social behavior, it's vital to reflect on how societal structures affect neural processes. Environments that foster inclusivity and collaboration can positively impact our emotional responses, enhancing social bonding and reducing aggression. In conclusion, understanding the brain's influence on social behavior opens a window into our shared humanity. Reflect on your own social interactions. What emotions surface, and how do they shape your behavior toward others? The dance of connection and conflict within the human experience is intricately tied to the complexities of our brain, reminding us that we are not isolated beings but part of a greater whole. Our brain, in all its mysteries, continues to guide us on this journey of social connection. As we stand on the precipice of a new era in science, the future of brain research promises to unveil even deeper mysteries about our most complex organ. Advances in technology and understanding are set to push the boundaries of what we know about the human brain. But what lies ahead in this uncharted territory? One of the most promising areas of exploration is the development of brain-computer interfaces, BCIs. These systems allow for direct communication between the brain and external devices, unlocking new possibilities for individuals with neurological impairments. Research from Elon Musk's company, Neuralink, demonstrates how BCIs could help restore movement to paralyzed individuals and provide new forms of treatment for conditions such as Alzheimer's and Parkinson's disease. Furthermore, neuroimaging techniques are rapidly advancing, enabling us to visualize brain activity with unprecedented clarity. Functional MRI technology is being refined, opening the door to real-time monitoring of neural activity, offering insights into cognitive processes as they occur. Another exciting frontier lies in the study of neurogenesis, the ability of the brain to produce new neurons throughout life. This phenomenon challenges the long-held belief that neurodevelopment ceases in early adulthood. Research has shown that engaging in physical exercise, learning new skills, and even certain diets can stimulate neurogenesis, offering pathways toward cognitive enhancement. Moreover, as we explore the potential impacts of artificial intelligence on the brain, researchers are examining how machine learning can augment our cognitive capabilities. In fact, some scientists argue that AI could serve as an extension of our cognitive processes, helping to enhance decision-making and creativity. However, with these advancements come ethical challenges that society must navigate. Issues related to privacy, consent, and the implications of altering our neural processes are becoming increasingly pertinent. As we develop technologies that interface directly with the brain, it raises questions about the future of human identity and autonomy. As we move forward, understanding the complexities of the human brain will not only benefit individual health but also redefine our understanding of what it means to be human. We must embrace a collaborative approach, one that unites neuroscientists, ethicists, and policymakers to ensure that advancements serve the greater good. As we conclude this final chapter, think about the incredible journey we've taken throughout this documentary. The human brain's mysteries are vast and largely unexplored, promising a future filled with wonder and discoveries yet to come. Let's continue to ask questions and seek answers, for it's through this pursuit that we will uncover the truths hidden within our minds and the potential that lies ahead. Remember, the future of brain research is not just about understanding the brain, it's about understanding ourselves. Imagine waking up one day and not recognizing the faces of your loved ones. For millions, this isn't a nightmare but a daily reality. Brain disorders like Alzheimer's disease and schizophrenia have long baffled scientists and families alike. These conditions challenge our understanding of memory, identity, and reality itself. With over 50 million people worldwide affected by dementia alone, the urgency to unravel these mysteries has never been greater. The brain is not only our organ of thought but also the very essence of who we are. Disorders such as Alzheimer's lead to a gradual, heartbreaking decline of cognitive functions. In 1906, Alois Alzheimer first described the disease after examining the brain of a patient who had experienced severe memory loss. What he discovered were tangled fibers and plaques that would later be identified as the neural hallmarks of the disease. Since that time, researchers have made significant strides. However, a true understanding of how these changes lead to symptoms remains elusive. But Alzheimer's is just one piece of a much larger puzzle. Schizophrenia, affecting about 1% of the global population, offers another layer of complexity. Imagine hearing voices or feeling as though someone is controlling your thoughts. For those living with schizophrenia, these auditory hallucinations can be terrifying. Research has shown that people with schizophrenia have abnormalities in various neurotransmitter systems, particularly dopamine. Yet, what triggers the onset of such a debilitating disorder? Scientists are still searching for answers. The mystery deepens when we consider the enormous variability in how these disorders manifest across individuals. Two people with the same diagnosis may experience vastly different symptoms. Could environmental factors, genetics, or even early childhood experiences play a role in this divergence? The field of epigenetics, the study of how environmental factors can influence gene expression, opens new doors when examining the interplay between genetics and brain disorders. Studies suggest that adverse childhood experiences can result in epigenetic changes that leave lasting marks on the brain, perhaps increasing susceptibility to disorders like PTSD or depression later in life. New technologies like functional MRI and EEG are helping scientists delve deeper into brain function as it relates to disorders. Imagine being able to visualize brain activity in real time while a person with schizophrenia hears voices. These technologies are providing insights into the neural circuits that may malfunction in mental disorders, leading to more targeted treatments. As we investigate brain disorders, we must also consider the societal implications. How do cultural perceptions of disorders influence treatment? In some societies, mental health conditions carry a stigma that discourages individuals from seeking help, leading to a cycle of suffering and misunderstanding. The future of neuroscience will likely involve not only a better understanding of the brain but also a deeper appreciation for the social and cultural contexts within which these disorders occur. By piecing together the biological, psychological, and social aspects of brain disorders, researchers hope to pave the way for new therapies that could drastically improve the quality of life for millions. Whether through better medication, psychological therapies, or even groundbreaking technologies like brain-computer interfaces, the possibilities are vast. As science continues to evolve, the age-old mysteries of the brain might finally yield some of their secrets. But just as we think we've got it all sorted out, new questions emerge, keeping us in a constant state of wonder. What will the future hold as we journey deeper into the enigmatic world of the human brain? What if the deepest feelings of joy, sorrow, and anger are not just byproducts of our lives but rather a complex language spoken by the brain? Emotions govern our decisions, influence our health, and shape our relationships. Yet, despite their undeniable impact, scientists are only scratching the surface of understanding how the brain processes emotions. The limbic system, often referred to as the emotional brain, plays a key role in processing emotions like fear and pleasure. Within this system, the amygdala is particularly famous for its role in fear responses. Imagine encountering a snake in the wild. Your amygdala triggers an instant fight or flight response, preparing your body to react long before you consciously assess the threat. But what about more complex emotions such as love or empathy? Scientists have identified various brain regions associated with specific emotions. For example, research suggests that the left prefrontal cortex is associated with positive emotions, while the right side is linked to negative emotions. However, these regions don't work in isolation. They form intricate networks that weave together our emotional experiences. Consider the last time you felt a powerful emotion. How did your body react? Our brains release neurotransmitters like serotonin and oxytocin during social bonding, giving our emotions a biochemical basis. The science of emotional contagion explores how emotions can be transferred from one person to another, like a ripple effect. Case studies also illuminate how emotional processing can differ among individuals. For instance, individuals with autism spectrum disorder, ASD, may struggle with emotional recognition, often missing social cues. This raises profound questions about the nature of empathy and emotional intelligence. What happens in the brains of individuals who perceive emotions differently? By using advanced imaging techniques, researchers are studying these differences to better understand emotional processing and social behavior. Emotions not only color our experiences but also influence our health. Chronic stress or unresolved negative emotions can lead to physical ailments, from heart disease to autoimmune disorders. The field of psychoneuroimmunology investigates the connections between the nervous system, the immune system, and emotional health. Can understanding this connection lead to new interventions that leverage emotional well-being for physical health? Imagine a world where mental and physical health are seen as intertwined rather than separate entities. As we unravel the mysteries of emotional processing, a new frontier emerges: the intersection of artificial intelligence and emotional intelligence. Can machines learn to understand human emotions? Companies are developing AI systems that read facial expressions and vocal tones to gauge emotional states. This presents both exciting possibilities and ethical dilemmas. How do we ensure such technology is used respectfully and responsibly? In the age of social media, where emotions can be broadcasted at lightning speed, how will our collective emotional landscape evolve? The brain's hidden language of emotions continues to reveal new layers of complexity. With each discovery, we come closer to understanding not just how we feel but why we feel. As we embark on this journey to decode emotions, we are challenged to consider how intertwined our emotional lives are with our physical, social, and technological realities. The mysteries are far from solved, and as our knowledge grows, so too does our capacity for empathy and connection. What revelations lie ahead in the emotional frontier of neuroscience? Have you ever felt a rush of excitement that made your heart race, or a moment of anxiety that left you feeling physically ill? The link between our mind and body is profound, revealing the intricate dance between our physiological states and our mental health. While we often compartmentalize our experiences, the truth is that our brains and bodies are in constant communication, influencing each other in ways we are just starting to understand. At the core of this connection lies the autonomic nervous system, which governs involuntary bodily functions like heart rate, digestion, and breathing. This system operates in two primary states: the sympathetic nervous system, which orchestrates our fight-or-flight responses, and the parasympathetic nervous system, responsible for rest and recovery. Picture a deer that senses danger. The activation of its sympathetic nervous system enables it to escape swiftly, while the parasympathetic system takes over once the threat has passed, allowing the deer to relax. This dynamic is not just a survival mechanism, it shapes our emotional experiences daily. Take stress, for instance. Chronic stress can lead to a host of physical ailments, from digestive issues to cardiovascular disease. Research has shown that the brain's response to stress includes releasing hormones like cortisol, which, while useful in moderation, can become toxic when levels remain elevated for prolonged periods. The implications for mental health are staggering. Anxiety and depression frequently coexist with physical symptoms, creating a cyclical pattern that can be difficult to break. In therapeutic settings, the connection between body and mind is harnessed in practices such as mindfulness, yoga, and meditation. These modalities emphasize body awareness and intentional breathing, which can help regulate emotional responses and promote overall well-being. Studies have found that mindfulness practices can lead to measurable changes in brain structure, including increased gray matter density in regions associated with emotional regulation and stress response. Imagine engaging in a routine of mindfulness meditation that not only calms the mind but literally reshapes the brain. Furthermore, physical movement plays a pivotal role in mental health. Exercise has been proven to reduce symptoms of anxiety and depression, partly due to the release of feel-good hormones called endorphins. The phenomenon known as runner's high offers a glimpse into this brain-body interplay, wherein physical exertion leads to a surge in mood-boosting chemicals. Exercise not only strengthens the body but also fortifies our emotional resilience. As we dive deeper, we must consider the potential of this mind-body connection in therapeutic contexts. Are there unexplored dimensions to how we can harness the brain-body relationship for healing? The emerging field of psychobiotics, studying the gut-brain axis, highlights the impact of gut microbiota on mental health. Researchers are investigating how the gut's health can influence conditions like anxiety and depression, suggesting that a comprehensive approach to mental health could include dietary modifications alongside traditional therapies. So, what are we to make of this intricate relationship? The implications extend into our everyday lives, urging us to recognize the power of our emotions and thoughts on bodily health. Could simple lifestyle changes help us break the cycle of mental health challenges? As we deepen our understanding of the brain-body connection, we stand on the cusp of revolutionary approaches that could alter how we treat mental health altogether. Journeying through this maze reveals that the mind and body are intricately intertwined, echoing the age-old wisdom that to heal the body, we must first consider the state of the mind. Aging is a universal human experience, yet the intricacies of how our brains age remain one of modern neuroscience's greatest mysteries. As we grow older, cognitive decline can set in, leading to conditions like Alzheimer's and other forms of dementia. But what drives these changes? Research shows that neurodegenerative diseases affect millions worldwide. In the United States alone, over 6 million people are living with Alzheimer's disease, a number that is expected to rise dramatically as the population ages. Scientists are investigating how factors such as genetics, lifestyle, and environment contribute to brain aging. A notable study from the National Institute on Aging suggested that inflammation in the brain may play a significant role in cognitive decline. This inflammation can be exacerbated by poor diet, lack of exercise, and even social isolation, highlighting the importance of holistic health in maintaining cognitive function as we age. One compelling story comes from the Okinawa region in Japan, where residents exhibit remarkable longevity and cognitive health. Researchers have identified several lifestyle factors contributing to the longevity of Okinawans, including a plant-based diet rich in antioxidants, regular physical activity, and strong social ties. These factors may protect against the effects of aging on the brain. Understanding how to promote healthy brain aging could revolutionize both neuroscience and public health. The critical question remains: how can we harness this knowledge to extend healthy cognitive years? As researchers delve deeper into the mysteries of brain aging, they uncover insights that may transform our understanding of longevity and the human experience. But what if the secrets to unlocking a more youthful brain lie hidden in the very DNA of our ancestors? As we venture further into this enigma, are we close to discovering the keys to lifelong cognitive health? Or are we merely scratching the surface of a much deeper mystery? Stress is often considered a negative force in our lives, but what if it could also be a catalyst for growth? The human brain has developed incredible adaptive mechanisms in response to stress, leading to increased resilience and even enhanced cognitive performance in some cases. Through the lens of neuroscience, we explore how moderate stress might activate neural pathways that enhance learning and memory. A study published in the journal Nature found that short bursts of stress can boost the production of neural stem cells in the hippocampus, the brain region associated with memory and learning. A compelling case study involves individuals who have experienced post-traumatic growth, transformations that occur after traumatic events. Many report a newfound appreciation for life, stronger relationships, and improved coping strategies. For instance, the research on veterans returning from combat shows that some individuals grow psychologically after their experiences, finding purpose in helping others and advocating for mental health awareness. This adaptability showcases the brain's potential for resilience in the face of stress. However, can too much stress lead to the opposite effect? Chronic stress is associated with various mental health issues, including anxiety and depression. Understanding the delicate balance of stress is crucial for mental well-being. As we explore ways to harness the positive aspects of stress while mitigating its negative effects, we delve into techniques such as mindfulness, exercise, and therapy that can foster resilience. The question of how to train our brains to respond positively to stress remains vital. Are we unlocking a new frontier in mental health? As we uncover the layers of our brain's adaptive responses, we must ask whether the challenges we face are truly detrimental, or can they be transformed into tools for growth and resilience? In an ever-urbanizing world, the impact of natural environments on our brain health is a critical yet often overlooked mystery. How does nature influence our cognitive function, emotional well-being, and overall mental health? Numerous studies reveal that spending time in nature can lead to various improvements in mental health, including reduced anxiety and increased happiness. The biophilia hypothesis, proposed by biologist Edward O. Wilson, suggests that humans have an innate connection to nature, which may explain the soothing benefits of green spaces. A landmark study published in Environmental Science and Technology found that individuals who spent time in green spaces reported a significant reduction in mental distress. For example, a group of urban dwellers who took weekly walks in parks experienced a noticeable drop in stress levels and improved focus. This finding underscores the brain's responsiveness to its environment. One fascinating case study involved the practice of forest bathing, or shinrin-yoku, in Japan. This practice encourages individuals to immerse themselves in the woods, allowing the environment to promote relaxation and well-being. Research has shown that forest bathing lowers cortisol levels, the stress hormone, and boosts mood-enhancing chemicals like serotonin. Furthermore, the phenomenon of nature deficit disorder highlights the consequences of reduced time spent outdoors, particularly in children. Studies suggest that lack of outdoor play may contribute to rising rates of anxiety and attention disorders among youth. So, what does the future hold for integrating nature into our daily lives? As urban planners and policymakers recognize the crucial role of nature in mental health, we face a revolutionary question: can we design cities that foster our innate connection to the natural world? As we explore this relationship, we're not just uncovering mysteries, we're rethinking how we live and interact with our environment. Our sense of free will is one of the most profound mysteries of the human experience. Are we truly the authors of our own thoughts and actions, or is there something deeper at play? Imagine waking up one day and realizing that every choice you ever made was influenced by factors outside your control. This idea challenges everything we believe about ourselves. Philosophers and neuroscientists have debated the concept of free will for centuries. In 1983, Benjamin Libet, a neuroscientist, conducted groundbreaking experiments that illuminated this debate. He found that brain activity indicating a decision occurs several hundred milliseconds before a person consciously feels the urge to act. This raises profound questions. If our brain decides before we do, can we truly say we chose what happened next? Libet's experiments showed that our brains are always one step ahead of our conscious awareness. Imagine a light switch being flipped before you even realize it's dark. This revelation brought forth a wave of questions about responsibility and morality. If our actions are predetermined by neural processes, what does that mean for accountability? Are we puppets on strings controlled by our biology? Throughout history, humans have sought to understand consciousness, autonomy, and choice. From ancient philosophers to modern neuroscientists, the journey has been one of speculation and discovery. Notably, studies show that while many daily decisions are influenced by subconscious processes, larger life-altering choices still evoke a significant sense of agency. Take the case of Viktor Frankl, a neurologist and psychiatrist who survived the Holocaust. He discovered that even in extreme circumstances, individuals can find meaning in their suffering, suggesting that our minds possess a unique power to choose one's response to circumstances, even when the choice appears bleak. His ideas challenge the notion of deterministic thinking, highlighting that while our brains are influenced by numerous factors, we retain the ability to shape our destiny. Furthermore, advances in neuroscience have unveiled the complex interactions between our genetic makeup, environment, and experiences. For example, the concept of epigenetics shows us that the environment can influence gene expression, adding another layer to the free will discussion. If our choices can alter our genetic destiny, then perhaps free will is not a paradox at all, but rather a complex interplay between our biology and our experiences. As we delve deeper into this ongoing inquiry, various studies explore the correlations between neurological patterns and behavior. Neuroimaging technologies, like functional MRI, show us how certain thought processes are linked to specific brain areas, suggesting a biological basis for our thoughts and decisions. This connection continues to challenge our perceptions of autonomy. In conclusion, while the paradox of free will remains unresolved, it underscores a fundamental aspect of the human experience, the quest for understanding ourselves. As we grapple with these philosophical and scientific implications, we may begin to appreciate the intricate web of influences that shape who we are. The next step in this journey might just alter our understanding of what it means to be human altogether. Join us as we explore more about the human brain and its intricacies. What lies ahead might just unlock even more mysteries of our existence. You may have heard the phrase, "Trust your gut," but what if your gut is more than just a metaphor? Recent research unveils a profound connection between our brains and our gut, leading to groundbreaking insights about mental health, emotions, and overall well-being. The gut-brain axis is now recognized as a pivotal system influencing how we think and feel. The human gut contains trillions of microorganisms that outnumber our human cells 10 to 1. These gut bacteria play a crucial role in digestion, but emerging evidence shows they also communicate with our brains. In fact, studies illustrate how gut microbiota can influence mood and behavior. One striking example involves a study where mice with altered gut bacteria displayed increased anxiety-like behaviors. When researchers restored their gut microbiome with probiotics, the mice exhibited reduced anxiety. This fascinating connection led scientists to explore the implications for human health. In one notable study published in Nature Microbiology, researchers found that individuals with depression often have a distinct composition of gut bacteria compared to those without. This revelation hints at the potential for developing new treatments for mental health disorders through dietary changes or probiotics. Imagine a world where a simple change in diet might alleviate depression or anxiety. Furthermore, the gut-brain connection extends to how we process emotions. When we experience fear, our digestive system responds almost immediately, creating that familiar knot in our stomachs. This real-time feedback loop hints at deep-rooted evolutionary mechanisms that ensured our survival. Historically, being in tune with our body gave our ancestors a survival advantage, enabling them to react quickly to danger. But how does this work biologically? The vagus nerve, a major player in the gut-brain connection, serves as a highway of communication between these two regions. It transmits signals about the state of the gut to the brain and vice versa. This pathway allows our thoughts and emotions to influence digestive processes and our gut health to affect our mood. Consider the case of a young woman named Sarah. Struggling with anxiety, she sought help and learned about the importance of nutrition. Through mindful eating and supplementation with probiotics, she witnessed a dramatic shift. As her gut health improved, so did her mental clarity and emotional stability. This story exemplifies how the gut and brain can collaborate toward better health. The implications of understanding the gut-brain connection extend to fields like psychiatry and nutrition. Researchers are now collaborating to explore how specific diets can promote mental health. The concept of psychobiotics, probiotics that benefit mental health, has emerged as a hot topic in scientific discourse. As we continue to uncover the mysteries of the gut-brain connection, it prompts us to reconsider our approach to health and wellness. Perhaps the next time you experience a gut feeling, you may be sensing a subtle message from your body, one that could lead to better mental and physical well-being. Join us as we delve deeper into the brain's incredible mysteries and explore how interconnected systems shape who we are. The journey to understanding human health continues in profound ways. The human brain is not just a passive receiver of information, it actively shapes our perception of reality. Consider this: two people can witness the same event, yet describe it in completely different ways. This is because our brains filter and interpret experiences through a complex network of neurons influenced by prior knowledge, emotions, and expectations. Every stimulus we encounter undergoes a transformation as our brain processes it. Research has shown that our perceptions are often colored by cognitive biases, which distort reality in subtle but profound ways. For example, a classic study by psychologists Daniel Kahneman and Amos Tversky demonstrated how people's judgments can be swayed by irrelevant factors, impacting their decision-making. This illustrates that our brain is not merely a mirror reflecting the world around us, but a painter creating a unique canvas. Stanford University's